I'm Daria, and I will speak about computer vision challenging in real life and what we are doing with computer vision in Accenture. Now, just a little bit about me. Yeah, I'm Daria, I already told it, and I have been working in Accenture for 7 years. Currently, I'm working as AI engineer with LLM and generative AI stuff, but before it, I have been working for 6 years as a senior computer vision engineer in Riga Liquid Studio with different clients, and I will show you some example about it. Also, I have some boring certificates you can see here, and it's my LinkedIn. If you want to connect, please do it. And of course, I'm human, I'm mom and wife. Just in case I really want to have work-life balance. It's a little bit about me, and we can chat after my topic if you want. And now, if some of you don't know what Accenture it is here in Baltics, just a little bit about our data and AI capability. We have more than 200 people in Latvia and Lithuania now, and even if you have some colleagues in Estonia, it's also option to work in Accenture remotely. We have more than 70 projects, and regarding upskilling, mostly we have some skilling for this one, and me personally working in all these areas projects. With reinforcement learning, with computer vision, with generative AI, and with advanced analytics and deep learning. And even if you want to apply some pure machine learning vacancies, please welcome. By the way, we are hiring computer vision engineers and LLM engineers right now. But today, I'm going to speak about computer vision. I think all of you know what computer vision is, right? But can you explain your, for example, 3-year-old child what it is? Can you explain how machine sees?
You think in the image way?
Yeah, in simple words. What computer vision is?
QR code recognition.
For example, yeah, but what is QR code and what's recognition?
Pixels.
Oh, itself, okay. Well, I'm usually explaining to my 3-year-old son that computer vision can split any pictures as a cubic. For example, we have some cubic game, and each cube is kind of pixel or some part of picture which we can see as a computer, and after that neural network can create a picture, like for example child can create a picture from cubes. But anyway, about some examples. For example, let's start from digital forest. It's one of computer vision project which I'm really proud of, because we was working with client from South Africa, and now it's really worked on production. But what digital forest is, we are using some camera traps, and if we can catch some animals, we should classify which type of animals it is. Because usually before computer vision was implemented in this project, we have some people, students, who just analyze tons of pictures and do like this. Okay, it's tiger, not tiger, tiger, tiger. Boring, right? You're not applying this job, right? And what we did, actually we create a model with now working with 85% accuracy. I will show you why it's not so accurate. And also our models are very light, because we have to use such traps. Actually, usually animals don't have interest what to choose, and it's working fine, but sometimes we still need human to exchange batteries. But the model should work remotely without any internet connection, and it means that all brain for our models we should have inside this box. And we are using TensorFlow Lite as the fastest and the lightest model which we can find. But the other challenges, what we have, it was dataset distribution. As you can see that it's completely unbalanced. And we even have human here, by the way. Who knows? Who you can meet in some jungle. And this, for example, some examples. And do you have any guesses who is here?
It's deer.
SpaceX.
SpaceX. And who is here? Someone.
I think 15% of error.
Yeah, 2015, yeah, but anyway, we just made a lot of preprocessing, normalization, and what we can do, and unfortunately, when we do all this preprocessing and have much better quality, we just have another problem.
Do you have some type of flashlight?
Yeah.
Infrared.
Infrared, yeah. But only one, only infrared. Here, for example, it's also a problem because we know that it's elephant, but it's not a whole elephant. And here we have only part of this bird. Okay, it's also we can see, yeah. But with normalization we can handle with it. But what we should do, for example, if we have tiger and gepard like this, it also could be a problem. But anyway, we are using detection, like a simple animal detection, and after that we implemented deep metric learning model to classify who it is. And we created a model which can classify for 2 seconds one picture from 2K quality and can easily analyze who it is. And
This is not Gepard.
who is it?
Leopard.
Okay, even me, human made mistakes, but our solution didn't do such a mistake.
The type of color.
Yeah. And this is confusion matrix, which we can see that actually it's a good results sometimes, but sometimes we still have misclassification, and I will show you some misclassified images. Now, for example, even with normalization we still have some problems. Who is here in the shadows and who is here? But anyway, unfortunately for this project, we just took jobs for 10 people, but now it's working with accuracy 85%. And sometimes AI solution can easily detect such shitty problems. Can you even notice that someone is here? But it's this bird. I actually don't remember how it's called, but you can see, yeah, that it's still under leaves. And now, for human, we have only one responsibility: to exchange batteries. And that's it.
But how it sends data?
It's not send the data. When you just come to exchange batteries, you extract the memory card.
Okay, but you didn't mention it. Okay.
Why do you have
I said with no connection and just changing batteries. So.
Yeah, just someone just need to once per 3 months to go and change batteries. You have a question?
Change memory cards.
Humans can be used here as well if we, for instance, insert this image to captcha.
Yeah, for
And
example.
choose all the pictures with kiwi bird.
Kiwi bird doesn't exist.
Yeah, but anyway, these solutions also catch humans. If we can see any hunters who don't have license, we also can catch them. someone else.
Why did you choose to do it on the edge? So why not just take a memory card when you're changing the batteries and then you could process it?
It was a requirement from client.
Like what was the reason for the requirement?
Self-Africa.
It was a requirement, yeah. Why they don't need internet?
Anyway, right? So it's not like it does anything at the time.
So like maybe let's rephrase the question. So did actually the classification happen on the device?
Yes.
Okay, so you already have the classified
Yeah.
images when you like take the memory card.
Yeah.
Okay.
We already have like product ready to go on the memory card.
How long did the batteries last?
Sorry?
How long did the batteries last on average?
3 months.
But to clarify, the question was if anyway it's taken away, manually brought somewhere, why to run on such small device and such constrained environment, if anyway it's uploaded physically somewhere, why not to process on like huge model with much better accuracy?
Yeah, but
The requirement, yes, but when it doesn't make sense, we usually tell to customer that it's not good requirement.
it's in a deep jungle.
But anyway, but the car, they bring it to somewhere.
Yeah, but can you guarantee that you have internet in a deep jungle?
No,
And-
we're talking about another question. Why you processing images inside device, but not taking this card with raw photos, inserting in some devices and processing in much bigger cluster with higher quality and higher power?
Because in such case we still spent 3 months. We lost 3 months.
So do you do anything with the
Why you
data
lost
on the
3
edge,
months?
like after you classify it?
How to write a record video of 3 months? It will be.
It's not video, it's
But it's
pictures.
photos anyway.
Yeah,
It's
yeah,
anyway
just
pictures. It's no difference in time. You place the card in 1st January, you took in 1st April, yeah? But the difference is card is these images are processed inside of device, or you just put it inside MacBook and after 5 minutes you have uploaded it
Well,
to
not the
cluster.
5 minutes, come on. It's not the 5 minutes, but I think it's just requirement from client. Maybe they just went to these devices more often than once per 3 months. Yeah, just to check it, yeah.
How many does it take?
How much pictures could it store?
In one device or in data set?
How much memory it have?
How much memory? I don't remember, but I think it has around 6 gigabytes of memory.
Processing some raw photos or already just JPEGs or something?
Yeah, it's compressed.
It's already
Yeah.
making compressed photos, not using RAW, which you can
Yeah, of course it's not rough, yeah.
which you can proceed with some exposure and something.
Yeah.
Great.
Any other questions regarding this?
Let's
We still have more!
I've been considering what's actually the value of a device powered with batteries somewhere in jungles when there are devices that can operate on just a movement detector, which consumes, in my opinion, much less power, so it can work for the same 3 or even more probably months. Why do you need model on that device? Or I mean, what's the value for the client to have this model on this device and detect do this in general?
Well, because...
I think
Well, let me try to answer. Well, I think because client just want to process on that device, and it was a requirement. And before this, usually people just doing this pre-processing, and that's why I just don't want to do it by people.
Maybe they already have these devices. Maybe they plan to improve something there. Maybe they want to bring internet to the jungle.
Yeah, maybe sometimes.
Okay, so it's for innovations actually.
there is too many false positives.
Yeah,
So
but the leaves are moving, so it's.
yeah, like the leaves, the streams, like everything is moving. There's too many false positives.
But they also made some experiments with different devices, and usually animals just paid attention to different devices. And it has a lot of problems that it was broken by animals, and they try to hide from different devices. Yeah, only with such type of devices it works.
I'm still interested in this classificator, human with gun. So Yeah, so how does it work? Like,
Well, it can detect that it is human, but it's not can detect who is it, for
yeah,
example.
but a human with a gun. Like,
It can detect that it's human. And
there was two classificators, human and human with a gun. So you
okay,
said,
yeah.
You said like there is detection of some hunters.
Yeah.
So they classify and then somehow try to understand.
Yeah, for example, if we have someone who don't have license to hunt in this area. Yeah.
How you can check licenses not in offline device?
For example,
it's a small jungle.
If no one have license in this place.
But you have offline, you're uploading all databases of licenses.
Yeah, but for investigation, how much time you should spend to investigate who actually kills this tiger?
It's 3 months.
Let's move forward. Only
If you found killed tiger, you can go to this device early, not in 3 months.
Okay, another case is also possible. Okay.
Yeah.
I think there's much more interesting. Can we continue? Yeah, because it's, yeah.
Yeah, and if you have more questions, I will be glad to answer after that, yeah. Okay, another project which came to us after this digital forest, it's quality inspector, anomaly detection. And the client, it's one of the global car producer. And what we actually did, we agreed with client to install cameras, 4K cameras, in different places of car assembly. And cameras just catch up different pictures, and after that, it can send them to cloud, to Azure cloud, and in Azure we have a normal model which can predict sometimes what we can detect or which we should classify. Should we detect is it okay or NOK? For example, we can detect did they install correctly airbag? And basically, do you know how a airbag looks like when it's installed? It's this small part. But if it would be rotated, and if it would install incorrectly with rotation, for example, or didn't install till the end, didn't install properly, it wouldn't work properly. And sometimes if you are driving and only airbag can save your life, if it wouldn't install properly, it means that you can die. And its quality inspector actually by save you from this. Of course, sometimes we also have people who, with eyes, make a quality control by this, but you can imagine that one plant can produce 800 auto per day. And basically for one inspection we have only 15 seconds. And it doesn't matter how big and how heavy your model, or if you use several models, 4, 8, it doesn't matter. You have only 15 seconds. Because client cannot stop car assembly. It's always moving, and if client have to stop car assembly, it will cost 30,000 euro per 1 minute. And that's why actually it depends on different use cases, and we can install cameras in any place of car assembly as we agreed with client, even if you don't have any vibrations, for example, which can be an obstacle for detection. But for this client, we already have been working for 2.5 years. And we already developed a lot of production use cases, I think around 500, over the world. In USA, in Germany, in China, in Mexico, and in UK. And currently the same solution will be implemented in South Africa as well. And if you have some cars, and if you buy some cars which were produced from 2020, you can be sure that sometimes it could be checked by AI, by computer vision. And it's one more example. Actually, its example is very important because these cars are produced in USA, but for China market. And we should detect this a small sink, small plate above the wheel. And if in USA they produce, are you hearing me well? If in USA they produce a car without this place, it could be really very big reputation risk. And sometimes for car, if we don't have such place, it should be okay. But even with human eye, you can see that it's really hard to see. How they did it before computer vision was implemented. They just came and checked every car by hands. 4 wheels, 800 cars per day. You can imagine how much work actually it is. And now they can do it without any workers, without any engineers who is doing it. And one more actually requirement from this client, all our models should work for 15 seconds, I already mentioned it, with accuracy 99.5%. Sometimes it could work with only 99%, but if you have accuracy less, it means that they will better use workers than computer vision.
But what is F-score?
It depends, yeah, but actually it's also, they also created confusion matrix for every use case, and every use case just has 1,500 pictures to test and 2,000 pictures for acceptance test. And they produce a special NOK, like basically broke the cars just to check that it's really worked. But for this client, we not even make some computer vision checks, but we also check a sound, but with computer vision. Here we can check how actually our engine sound when car is already make some first driving check. But every sound we can create to spectrogram, and if we can see in spectrogram some special peaks, it means that we can hear some noises in engine, something wrong. And if I remember correctly, basically I personally had some problems when my engine of my car has been broken, and it was because someone in a plant didn't check that it had some noises in engine. But if you don't have some noises, everything okay, engine is working properly, how it should, and it means that it's okay, quality check is okay. But what challenges we have here? It should be completely silent. When we recording these noises, this actually sound of engine and microphone, it should be completely silent inside of the car. And of course in plant, it's really hard to create such area when we can do it. And we also do some pre-processing with the sound, try to make it more clear from different noises and to find only one noises, what we're really interested in. And I would say that for this use case, it's also 99% of success because of data. But anyway, it's still working, but only for electric cars. Yeah, because it's not so much different noises inside, yeah. Yeah.
But hasn't it been trying to put like some microphone on the engine or something to record?
No, it's not
like
in the engine, it's inside where his driver sits.
Why? Why do not put it into engine bay?
Well, because its engine, it also have some temperature or something, and it also have some problems where installed it is, and that's why they are putting microphone only where in the place when we have a driver inside.
And the spectrogram, is it hertz? Do you measure in just hertz? How the length of the wave?
Yeah. No, we are just looking
And
these
this
peaks.
is a heat map or not?
It's spectrogram.
But what spectre? Spectre of what?
I don't remember this technical. Yeah, but it's definitely spectrum.
Frequency and amplitude. So the brightness of the pixel is amplitude. The axis is usually vertical is time, and horizontal is the frequency.
Concerning, no, I think time is horizontal.
Time is horizontal.
Well,
Yeah, usually time is. Okay, and after that we also create one more project. I think some of this room even participated in this project, and now it's still alive. What's the idea? How many money you actually spend for a doctor's? Infinity, right?
For alcohol?
Alcohol is not a good doctor, I would say.
You can try.
But what if you need to have some recovery, for example, after surgery, or if you have some problems or trauma after some sport exercise, and you need to visit physiotherapist? And you know actually how much it will cost if you visit physiotherapist, for example, 10 times.
1,000.
Yeah. Around 1,000. And what we actually suggest in this project that you visit physiotherapist only once, and he or she prescribe you to do some exercises, to make some complex of exercises what you are really doing, and you can do these exercises at home or whenever you want, in front of your camera of your phone or your camera of your computer, and this solution can in real life, in real time, analyze how correct you're doing this exercise and that you are doing correction exercise. And after that, your physiotherapist just got all this data, and when you have like last visit, 2 visits, one to have a prescription and one to make some analysis, and after that, physiotherapist does make a conclusion: are you recovered or not? And what we did actually, we collect like tons of data, around 40,000 videos for 5 types of exercise, and we make in every video skeleton detection, and for every skeleton detection for 7 frames, we just create sequences. After that, you use LSTM for exercise classification. And after that, we can classify, for example, if it's a bike exercise, how correct you are doing it, and how correct, for example, you're doing with your legs, and how correct you raise your hands, how correct you make your knee, and something like that. I have a demo, what we actually created. I hope it's worked. It's working, no? No? Oh, yeah, it's like this. You see? I think some of you already did such exercise before. It's from USSR, I would say, and a lot of physiotherapists in Latvia just prescribe to do such exercise. But you can see that it also can analyze how correct angle you have for your hands and for your legs. And it also could work in real life, but if you are doing it in front of your mobile phone, of course, you should send it to AWS, for example, or to Azure, and we have a model inside of cloud. But yeah, you can do better. And we even doing some tests, for example, what if someone just want to do it outside? For example, if you have some country house, or if you just want to do it in a nightclub just in case. Yeah, you will see such examples. Yeah, for example, here this person is doing exercise what we don't know. And basically we also just provide GDPR because you cannot see who it is, right?
Sure.
You cannot see the face.
But we can see plates of the car.
Yeah. Yeah, for example, if you want to do this exercise in a country house, it's also possible. Of course, maybe not under rain and snow. Yeah, but anyway, just in the summer you can do it. And yeah, if you want to do it in a nightclub, it's also possible. Why not?
Have you considered to adding this into Microsoft Kinect?
Yeah, actually we did some experiments, but it was a requirement from client, don't use any Microsoft. Because client approved only AWS.
You have very challenging clients.
Yeah, it's only
But it's
one
only
of the part of JAWS, yeah.
Very interesting requirements.
Okay, and just to have another project, we just currently we have another project with now live, and for this project we are using all pods actually what we just created during this project. I will show you a little bit later. And also one more challenging example I think here. To be honest, if you have some question why client ask us to do it in this way, I have no idea why. But the main idea is that we have a global chocolate producer. And they really want to analyze a stopwatch and get emails if stopwatch change the color. The idea is that if they have a leaking of milk, watcher will change a color to white. If they have a leaking of chocolate, watcher will change the color to brown. Or if we have leaking of something else, it also could be brown, but okay. Just use your imagination. And how actually we did like this, we also collect a lot of data set, but watcher has reflections. And if we have some different light conditions, for example, it's all milk, but it's milk without reflections, it's milk maybe without something, and it's milk with reflections, what we did, we detect some part, for example, do we have any reflections part, or do we have part without reflections, and only after that we just classify them separately. And if they both classify, for example, as a white, we will have we can say, yeah, it's really white, it's milk. But if we have some problems, for example, one is white and one is, I don't know, yellow, it could be yellow, right? In such case, we can make a decision only based on probability. And which color has been predicted with a higher probability, it means that we can predict it's this color. And I also have a demo actually from the toilet, how it works. But yeah, you can imagine it's a stock pipe, and we have some water, we have a camera, and light, and we can predict which color it is. For example, it was white, it's now blue. And we also collect all results in database, and client got an email that, yeah, something's wrong, color has been changed, and they need to do some actions. But when we install it to client, it was really looks like this, because they have a very dark room when we can check this water, and when we ask why you don't want to do something else, for example, to make analysis, some chemical check or something, they really want to bring such innovation, yeah, but it's anyway it works. And now our current project, what we are doing now, it's active speaker. I think in this project we just create all our previous skills and all our previous experience. And what we should do in this project, we should detect, it doesn't matter that it's Marvel movie, it's not a Marvel client, it's just for example, we just need to detect who is speaking on the screen, and it should work for movies and cartoons. Who is this character? What he or she or it is speaking, and how his or her or its lips are moving. Because client is really want to have such solution to create automatic subtitles and to help for next dubbing of these movies. What we did, we are using voice detection just to understand what is speaking. We are using face detection just to understand how many persons or creatures we have. And after that, we try to analyze lips movements and also create sequences. Remember, I told you about sequences from exercise project, from 10 frames now. And we just need to analyze how lips moving, just to identify who is really speaking from the persons or characters what we have. Combine it with voice detection by time, and after that we need to understand who is speaking what and how. Unfortunately, I cannot show you a demo like a video, but because now this project is ongoing and I cannot name who is the client. But anyway, for this project we have 92% of accuracy, but it's very slow because you see how much models we have. The client requirements to process one regular movie 1.5 hours for 24 hours. And basically it's normal speed, 24 hours. But I think it's the most challenging project what we have now, because now it's working only for humans or aliens who are looking like humans, for example Gamora, yeah, from Guardian of Galaxy. But for Rocket Raccoon it didn't work yet. But we are working to create data set from characters as well, from cartoon characters, but it's really huge of work. Yeah. I think that's all demos and projects which I want to have. Yeah,
regarding the last one, yeah. So currently there are like huge corporations creating huge multimodal models and kind of I can chat already with video or audio or so on. Does it make sense to do any work in this area, or just like wait 12 months and it will be solved and we can just save some money for us and for customers?
Well, we don't know that it will be solved in 12 months and client just want to have it now. Usually. usually, yeah, like every client wants to have that every solution should work yesterday, remember?
But it's not like 2 months project anyway.
Yeah, I know.
So.
But they want to do it.
Okay.
For 2 months.
Okay.
Actually 1.5 months.
Okay.
What about a situation when somebody speaks in the background?
Yeah. In such case, we are trying to detect who is speaking, I mean, to label who is speaking what in a voice detection, but it's not working well, I would say, now. But without like labeling dataset, I think it won't work. And also we had a problem if we have very strong music in the background.
And what's about a specific like accent?
Accent? Well, now it's working only for English speaking. Yeah, but if someone has an accent, in such case we also should add it to dataset, I would say.
But the biggest problem, I think there was some scientific paper about this, why this is like a bit unsolvable, that in movies they quite often have that two people are talking, they are shown, and then they are showing some landscape, and the people keep
still talking,
keep some dialogue, and you have no video of who is talking. That's it basically.
Yeah, but it's also kind of not helping for dubbing, I would say. In such case you can even label the voices, and in such case you can label the voices and faces of actor. Yeah, but for example, if we have Hulk, how we can know that how he's speaking someone.
The thing is, we could already generate the sound of someone's voice. So that is why I think it's solvable to understand who is speaking right now.
You have a question.
Yeah, actually, have you considered using some open source models like...
We tried actually, yeah.
And actually that was, I was quite curious because usually Whisper API provides way better accuracy, like 95 to 98.5%. So I was wondering why the accuracy was so low, about 92% mentioned?
Yeah. But it was like accuracy of a whole project, who is speaking what, yeah, not like what is speaking.
But in the end, have you ended up using some open source?
Yeah, we tried to use TalkNet, but of course client requirement. Client doesn't want to use any open source which will train on celebrities. It's a requirement.
So have you fine-tuned some models? Or
yeah.
Fine-tuned?
Yes. For example, here for face recognition, we fine-tuned YOLO 5, and it's actually media pipe. We detect lips. But we also realized that media pipe also kind of train on celebrities, and now we are trying to extend it to open pos. Yeah, but I think it also should be fine-tuned.
For voice recognition, was your proprietary own model, right?
Yeah. We tried TalkNet, but...
Question, maybe you could comment why the training on celebrities is not the best?
It's a client requirement.
You don't know any technical reason why?
Yeah. They just, it's like legal client requirement. It shouldn't be like this, and that's it.
And for the first model that you have, each camera is located kind of in the same place, so it could understand what is happening and could understand something new at the picture. Do you use this in your model?
It's for digital forest?
Yeah.
No, we didn't. But maybe in the future, yeah, we can.
Because every camera kind of know what is the background of each photo. And
yeah, but it's also changing because it's in the forest. It also has some rainy, some maybe mosquitoes or something. Yeah, it's also changing. It's not always constant. We are not in a game.
Kinda, yeah.
Okay, any other questions? Yeah.
Have you tried to use script from the movie?
Sorry? a little bit louder.
When we film movies, we actually have scripts with people.
Yeah.
Can we try to like utilize that in any way?
Yeah, we tried, but sometimes actors has improvisations. Yeah, and we should detect what they're really doing in a screen, not like the scripts.
Actually, this is a good idea because modern movies, like audio recordings, made with Atmos technology, which kind of locate the sound in the space and records the three-dimensional sound, let's call it this way. So it may help to separate different sounds.
Yeah, maybe, but it's also cost questions.
And requires access to the sources.
Yeah.
Okay, seems
Someone else. Sorry.
About the liquid color detection. So, like in the forest, you have really basically no control of that environment. When it rains, it rains and so on. When it's night, it's dark. But in the liquid scenario, in theory, you could, or was that a requirement by the client, as it happens a lot, it seems, that you, for example, cannot use your own light source and, like, for example, always use a white background, so you can, like, actually detect the color with easier to detect, like, which color it is. Even like if there's some reflection, the red on white will always be red, and the reflection will be just white on red, which is on white, so but the colors are still the same. So you had to use like just the camera, you had no possibility to use like some technical interventions in the place where that's going on to help with the solution?
Of course, we could actually use some special additional lights. Why not? And we can exchange background for pipes, and we did it actually, but we still have reflections because it's a pipe. Sometimes we cannot predict reflections where it could be.
Oh, I mean, depending on the place, like if you know the pipe is going to be there and it's not going to move, like where you set up the camera, then you can set up some kind of background or lighting, which will be the same most of the time. Like maybe if someone comes into the room and flips the light switch, then something changes, but it's going to be quite constant, so you have less things to detect that way.
Yeah, but the
was
water is
even
not
a technical possibility to do in that case. Like, would that make your solution and your job easier, or it was like, yeah, we can't do that, or that's not even actually gonna help so much, so we don't even bother with that. We just like try to get something out of the picture. Doesn't matter, dark light, whatever.
It's definitely might made it easier, but we have different amount of liquid. And actually, I don't know how to say it in English. It's also different amount, how strong this amount of liquid.
Basically, volume and the flow rate, speed, density. So you don't always know where to look. Like it can be like one red drop, and it can be a huge puddle.
And it's also affects.
So that is not also that is not constant. Yeah.